Okay, so this next lesson we're going to be talking about the large intestines. So the anatomy begins at the junction of the small intestine and ends at the anus. It forms an arch around the loops of the small intestine, so it surrounds the small intestine. So the four major parts are the cecum, the colon, the rectum, and the anal canal. It's approximately 5 feet long. It has haustra, which are a series of pouches along the large intestines, and that's how you tell the difference between the small and the large intestine is these haustras. The tennae coils are muscular bands that form the haustra, and I'll show you where the haustra is and what it looks like and what the tennae coil looks like also. So the cecum is a pouch-like portion below the junction of the ileum and the colon. The vermiform appendix attaches to the posterior medial side of the cecum, and the colon has 4 parts. So there's this ascending, transverse, descending, and the sigmoid. Looking here, so you have your liver right here across the top and your spleen. This is your stomach right here. So we're going to start as small bowel. So it comes in from the ileum into the cecum through the ileocecal valve. Here's your vermiform appendix. So you have your cecum with your vermiform appendix coming off it. You have your ascending colon coming up, and you have your right colic or hepatic flexure. I call it the hepatic flexure. You have your transverse coming across the middle. Then you have your splenic flexure or your left colic flexure. Coming down is your descending colon, and you have your sigmoid colon. It goes into your rectum to your anal canal. Looking at the where the small intestines, large intestines come together, so you have your terminal ileum. So this is your ileum to your terminal ileum, and then you have your ileocecal valve here, and we need to check that integrity of that valve. The valve, if there's any kind of bowel obstruction, that valve is going to help us distinguish what's going on within the bowel, and you'll learn about that when we get to pathology. So you have your cecum here. If I can ever find my mouse, there it is. Here's your cecum and your vermiform appendix, or just appendix here. This is a barium enema, as you can see. So if we start over here, this is your cecum, and you can see your appendix hanging down right there, filled with barium. Coming up your ascending, you have your right hepatic or colic flexure coming across your transverse. That right there looks like a little diverticulum. So that's what they look like. That's a good shot of it right there. Kind of a strange place, but they can be anywhere. Coming across is your transverse, and then you have your left colic or splenic flexure with your descending. Very common to have redundant bowel loops, so this is what we call redundant bowel loops here. It makes it so it's hard to see within it. So you have your descending colon coming down. You can see a few more ticks here. And then we go into your sigmoid, which is real swirly. It's an S shape, so you can see the S here on its side, coming down into your rectum to your anus, to your anal canal there. Looking at a MSP view, so we have, this is your S3, so we're looking here at your rectum coming down your rectal ampulla to your anus. This is your anal canal with your anus. Here's a blown up portion of this area. So coming in, this is your terminal ileum coming into your cecum. But this is really important to show you that this is your tennae bands. So it's a longitudinal muscle here that keeps it all together. And here's your haustra, the sac-like portions. So with these haustra, that's how you tell the difference between your small and your large bowel. I get that question from the students a lot. How do I tell the difference between large and small bowel? So we talked about how the jejunum looks feathery and how the ileum is a little bit smaller in diameter, and then we have these haustra for the large bowel. Okay, so that's how you tell the difference. So we have the right colic flexure, which is sharp angles at the ascending and transverse, also call that the hepatic. Then you have your left colic flexure, which I call the splenic. It's your sharp angle at the junction of the transverse and the descending. You have your sigmoid portion that forms an S-shaped loop at the end of the rectum at the level of the third sacral segment. So the rectum extends from the sigmoid to the anal canal, and the anal canal terminates at the anus. Now look in here, this is a full diagram. We've got the ileum, terminal ileum, coming in through the ileocecal valve to the cecum with your appendix hanging down. You have your ascending colon, you have your right colic flexure, hepatic flexure, you've got your transverse colon, your left colic flexure, or your splenic flexure. Down your descending, you got your tenate coil coming down. You can see the stripe there, so that whole stripe is that longitudinal muscle, and you got your haustra, so all these little pockets, each one is a haustra. Then you have your sigmoid colon here coming down to your rectum, to your anal canal, to your anus. So the function of your large intestine is to reabsorb fluids. It recycles water back into your body, so and it also eliminates waste products. So we're going to talk about the examination methods, contrast material preparation of the intestinal tract, the barium enema apparatus, and we'll get more into that when we talk about the positioning for a barium enema and the prep for BE. So patient care and prep, what we're going to be doing is making sure that the patient is well informed what we're going to be doing, because the doctor typically doesn't tell them. We're going to talk to the patient about tip insertion, and we need to know if we're doing a single BE or a double contrast BE, because that's going to change our setup. So the single contrast, you don't need the air tube tip, so you just have a tip with a balloon on it, or if there is a air line, you can go ahead and tie that off, so you know that there's no air going to be used on the patient. And usually the bag is pre-filled with barium powder, and you just add water and shake it up and mix it. The double contrast is usually you will add barium to it. It has a tip with a hose for the balloon and a hose for the air. You're going to hook up a sponge-filled plastic apparatus that you're going to use to blow up the balloon, and then you're going to have a blue ball that you're going to use to put the air in. So it can be performed in 2 steps. You can do like a single contrast barium enema and then drain everything out, and then do the air contrast barium enema. A lot of the times we just do it as one, so we'll fill the colon halfway, drop the bag, drain it, and then put air in, and it pushes the rest of the barium all the way around to the terminal ileum, to the cecum. So there's commercially prepared barium sulfate products generally used for retrograde exams. So they're higher density barium sulfate. It's the newest product. It absorbs more radiation. It's better for a double contrast exam. So make sure you grab the right barium. Errors usually is used in double contrast studies. You can use carbon dioxide. Also, it's easier on the patient, but it's usually a machine that you have to use. So instead of doing it by hand. There's water-soluble contrast that can be done orally or retrograde filling. When you're not allowed, like if the patient has really bad irritable bowel syndrome, we're worried about perforation, we can actually administer it orally. So we don't necessarily we won't use a gastrographin or an iodinated-based water-soluble contrast when we're doing a double contrast study. We need that barium. All right, so that was it. Easy, easy, easy.